On a delightful night of August 15, 1977, an incredible event etched itself into the history of the Ohio State University Observatory in the United States. Jerry Eman, an astronomer passionate about his work, was reviewing data captured by the university's telescope. What he discovered at that moment was so astonishing that, overwhelmed by intense excitement, he highlighted the relevant data on a sheet of paper, writing a note beside it that mirrored his astonishment. This instance led to the birth of the famous "wow" signal, a term that perfectly captures the mystery that still fascinates us today. The true origin of this radio signal remains a complete enigma. The intrigue surrounding this event deepens when we recall a 1959 study by two Cornell astronomers, suggesting that advanced civilizations in the cosmos might use a very specific frequency to attempt communication: 1420 MHz. This frequency is unique because it corresponds to the hydrogen line, the most abundant element in the universe, hinting at a sort of universal channel for intergalactic contact. The wow signal was detected precisely at 1420.3556 MHz, an astonishing coincidence that borders on the unbelievable. Since the wow signal was received, it has been the subject of much discussion and speculation. Originating from the direction of the Sagittarius constellation, it has inspired numerous astronomers to search for solar systems similar to ours, in hopes of finding signs of life. This search leads us to wonder, what if the wow signal was the first indication of extraterrestrial life that we have yet to identify? To make this journey into the unknown even more intriguing, in 1961, astronomer Frank Drake introduced a formula to try to calculate how many intelligent civilizations might exist in our galaxy. This formula, known as the Drake equation, serves more as a starting point for reflection than a precise calculation, encouraging us to venture into the vast unknown with what we know from science. Even the most conservative estimates suggest that we might not be alone in the galaxy. This scenario brings us to a fundamental reflection. If there are so many possibilities for intelligent civilizations to exist, why haven't we found any? This question is one of the great mysteries of science, fueling our imagination and our relentless search for answers in the universe. So, as you delve into this story, think of exploring the cosmos as embarking on an endless journey of discovery, where each discovery leads to more questions. And perhaps, in some distant corner of the universe, someone or something is pondering our existence in the same way. The Fermi paradox, an idea raised by physicist Enrico Fermi in the 1950s, presents us with an intriguing contradiction. As we expand our knowledge of the universe, we find more and more planets that could theoretically support life. The universe is so vast, with so many stars and planets beyond our imagination, that the likelihood of life existing beyond Earth seems almost a certainty. Yet, despite this expectation, the deafening silence of space wraps us in a cosmic solitude, suggesting that we might be more isolated than we thought. This dilemma is the essence of the Fermi paradox. If the universe is so hospitable to life, where is everyone? Why haven't we stumbled upon evidence of other civilizations, or why hasn't any of them attempted to contact us? This intriguing question has been debated by scientists, astronomers, and astrobiology experts for years, generating a wide range of hypotheses and theories to try to resolve this disparity between the high probability and the observed reality. One of the most fascinating and, perhaps, darkest explanations is known as the dark forest hypothesis. This metaphor compares the universe to a dark forest at night, where any noise might reveal a predator and visibility is scarce, suggesting that the universe could be a risky place for civilizations that stand out. The theory suggests that more advanced civilizations might prefer to remain hidden, avoiding sending signals that could reveal their location to potential threats. From this perspective, the common practice of actively seeking extraterrestrial contact could paradoxically be a risky maneuver. Not only does the dark forest hypothesis offer a viable solution to the Fermi paradox, but it also introduces a principle of caution for humanity on its journey toward intergalactic contact. It implies that perhaps the deafening silence of the cosmos does not indicate absence, but the presence of prudent civilizations hiding in the darkness, cautious not to attract unwanted attention. This perspective prompts us to rethink our approach to searching for extraterrestrial life, leading us to deeply question the implications of our own exposure in the cosmos. In a universe that might be observing us, the question broadens. It's not only about where everyone is, but also whether we should actively seek them out. Whispers in the cosmos may be wiser than shouts. This phrase captures the unsettling essence of the dark forest hypothesis in relation to the Fermi paradox. Thus, the vast silence we encounter when pointing our instruments towards the sky does not suggest emptiness but caution. In a universe where every star we see could have planets orbiting around it, the lack of signals does not indicate solitude but perhaps a survival strategy of advanced civilizations. At the core of the dark forest hypothesis is the suggestion that, aware of the countless unknowns of the universe, all civilizations choose to hide, seeking to avoid the gaze of others who might possess superior technologies and uncertain or even hostile intentions. In this context, our constant transmissions into space over the last 100 years could be seen as an act of naive boldness. Civilizations up to 100 light-years away could theoretically already be aware of us, raising questions about the wisdom of our cosmic visibility. The challenge we face is understanding why an alien civilization would decide to eliminate another simply for being aware of its existence. To delve deeper into this reflection, we need to momentarily distance ourselves from human evolutionary traits and flaws. Despite our imperfections, in critical moments, we have the ability to prioritize the survival of our species above all else. This instinct for self-preservation is perfectly logical from an evolutionary standpoint. Species that do not fully dedicate themselves to their continuity tend to disappear, losing the space and resources necessary for their existence. On Earth, this process resembles a competition where the most adaptable and resilient species have an advantage. Within the framework of the dark forest hypothesis, the cosmos can be seen not just as a vast array of opportunities but also as a realm of strategic caution. It's plausible that civilizations scattered across the universe might prefer silence, adhering to the principle that survival may not depend on who speaks the loudest, but on who can remain unseen. From this perspective, the search for extraterrestrial life becomes even more complex, requiring not only cutting-edge technology but also a deep understanding of the survival tactics other civilizations might be employing. The dark forest hypothesis casts a grim light on the fate of galactic civilizations, including our own, based on two simple yet profound premises. The first is that the primary goal of any civilization is to ensure its continuity over time. The second premise suggests that as civilizations spread through the universe in search of new territories to colonize, the available resources remain finite and unchanged, becoming increasingly scarce as expansion continues. This prediction of scarcity amid ongoing expansion suggests a future where humanity may face constraints within our own solar system, Rapidly advancing technology might eventually enable us to colonize other planets within the solar system. But even these resources will, sooner or later, prove insufficient to meet our growing demands. Reaching this critical point, it will be essential for humanity to seek and colonize new solar systems to continue our expansion and ensure survival. The discussion becomes even more complex when we consider encounters with less advanced civilizations in other solar systems. According to the straightforward yet ruthless logic of the dark forest hypothesis, a civilization might view the elimination of technologically inferior civilizations as a viable means to ensure access to the resources necessary for its own survival and continuity. This perspective deeply challenges the ethical and moral principles that should guide the actions of a civilization, as well as the future of harmonious coexistence in the universe. The hypothesis portrays a cosmos where survival and expansion come at the cost of extinguishing potential competitors for resources, highlighting the urgent need to develop an ethic for space exploration. Such an ethic must strike a balance between the pressing need for survival and a deep respect for life in its various forms. The dark forest hypothesis invites us to carefully reflect on what the future of interstellar interactions might hold, while also emphasizing the need to think deeply about how we intend to navigate the vast and mysterious stage of the universe. This challenge underscores the importance of developing not just technological advancements but also an ethical consciousness that guides our journey through the cosmos. It is crucial to promote an approach to exploration that honors and preserves the rich diversity found in the universe. In a cosmos where resources are limited and survival becomes the primary concern, the notion of predatory civilizations eliminating others to ensure their existence and access to resources transcends science fiction, becoming a concerning possibility that aligns with the rigorous logic of the dark forest hypothesis. This perception of the universe as a potential battlefield for scarce resources forces us to re-evaluate not only the existence of extraterrestrial life but also the strategies we must employ when considering our expansion beyond the solar system. The growing interest in asteroid mining, transitioning from mere science fiction to a subject of serious debate and legislation, reflects an awareness of resource limitation. If we are already seeking ways to obtain resources from celestial bodies at our current technological level, it is reasonable to imagine that more advanced civilizations may resort to even more extreme methods in their quest for vital materials. This includes the potential elimination of competitors to ensure supremacy and unquestionable access to such resources. The uncertainty regarding the intentions of unknown civilizations adds an extra dimension of complexity to the debate. Without the ability to know whether other civilizations would be friendly or hostile, the safest choice, albeit ethically debatable, may seem to assume a defensive or even offensive position to ensure one's own survival. This conjecture confronts us with profound ethical dilemmas about how we would act in the face of the possibility of contact with other civilizations. By suggesting that concealment and possibly preemptive action constitute the best survival strategies, the dark forest hypothesis challenges our most basic principles about the right to existence, as well as the value of cooperation and mutual understanding. At its core, the dark forest hypothesis underscores the need for us to adopt a careful and ethical stance towards space exploration. As we reflect on our role in the universe, it is imperative to consider not only our technological advancement but also our moral obligations. We must aspire to be explorers who value the diversity of life in the cosmos, seeking knowledge and understanding, rather than behaving like conquerors who view the universe merely as a resource for exploitation or a domain to be subjugated. Thus, contemplating the dark forest hypothesis alerts us that the choices we make as we venture into space will not only define our future, but also the ethical legacy we leave as humanity. The dark forest hypothesis paints a grim picture of cosmic interactions, suggesting that the safest approach for a civilization in the struggle for galactic survival is to remain unnoticed, keeping quiet. In this unforgiving universe, governed by the harsh laws of survival, eliminating potential threats before they become concrete dangers may seem like the most prudent option. This scenario challenges our inherent enthusiasm for exploration and interstellar communication, fueling the fear that any effort to establish contact could inadvertently expose humanity to dangers. If we indeed inhabit a cosmos where existence is akin to a silent arms race, then the wow signal takes on a new dimension. This fleeting moment of communication, if originating from a civilization attempting to reach out, could be the solitary echo of a long-gone entity, serving as a warning about the risks of standing out in the vast darkness of space. This context challenges our curiosity and shakes our optimism about humanity's role in the universe. The idea of a hostile universe, where silence is the key to survival, directly conflicts with our desire to explore the cosmos, make contact with other forms of life, and better understand our place among the stars. From the perspective of the dark forest hypothesis, our thirst for discovery and connections may be viewed as naivety, a lack of awareness of the tacit laws governing galactic survival. Despite its unsettling nature, the dark forest hypothesis also serves as an invitation to introspection. It encourages us to reflect on the complexity of life in the cosmos and the strategies we must adopt not only to survive, but to thrive in a potentially hostile universe. This reflection may inspire new methodologies for space exploration and interstellar communication that reconcile our natural impulse to discover and establish connections with the caution necessary to navigate a universe filled with uncertainties. The discussion surrounding the Black Forest hypothesis prompts us to question: should we let our safety prevail over our curiosity and desire to make contact? Is there a middle ground that allows us to reconcile these two tendencies? And, on a deeper level, what would be the cost of survival in a universe that may be hostile? I invite everyone to share their views and reflections on this fascinating hypothesis. Do you think humanity should be more cautious regarding interstellar communication? Or do you believe in the value of persisting in our attempts at contact, despite the risks involved? Expanding this discussion is crucial to better understand the complexities of existence and interaction in the vast universe. I greatly appreciate your participation and look forward to seeing your opinions and ideas. Until next time.